Our lesson for today is about the distance formula. The distance between 2 points, whether or not they are aligned horizontally or vertically, can be determined using the distance formula. Take a look at this. Consider the point P, whose coordinate is x sub 1, y sub 1, and point Q, whose coordinate is x sub 2, y sub 2. The distance d between these points can be determined using the distance formula. D is equal to the square root of the square of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. For example, find the distance between point P and point Q. In point P, we have 3, 5, and point Q, we have negative 5, negative 1. So, you are going to let x sub 1, y sub 1 as the point P and x sub 2, y sub 2 as your point Q. After that, you can now substitute these values to the distance formula. Okay, so you are going to write first the distance formula. Line segment PQ, okay, so we use line segment PQ here because we are looking for the distance of point P and point Q. So we have line segment PQ is equal to the square root of the square of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. And then, substitute, your x sub 2 is negative 5 minus x sub 1 is positive 3. Okay, so we have negative 5 minus 3 squared plus y sub 2 is negative 1 minus y sub 1 is positive 5. So we have negative 1 minus 5 squared. And then you can simplify your answer inside the radical symbol. So we have negative 5 minus 3, that is negative 8. Negative 1 minus 5 is negative 6. And then simplify further your answer. Negative 8 squared is 64. Negative 6 squared is 36. That's why we have 64 plus 36. And then you can add them. 64 plus 36 is 100. And after that, for the last part, you are going to get the square root of 100, which is positive 10. Meaning to say, class, the distance between point P and point Q is 10 or 10 units. Let's have another example. Find the distance between point M, negative 3, 4, and point N, 6, negative 2. So first, you are going to let x sub 1, y sub 1 as your point P and x sub 2, y sub 2 as your point N. And then, you can now substitute the corresponding values in the distance formula. First, you are going to write the formula. Line segment MN is equal to the square root of the square of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. And then, substitute now the values. We have square root of, ayan, x sub 2 is 6 minus, your x sub 1 class is negative 3. That is why we have 6 minus negative 3. Then square. Plus, y sub 2 is negative 2 minus y sub 1 is 4. So we have negative 2 minus 4 squared. And then you are going to simplify your answer inside the radical symbol. So we have 6 minus negative 3, positive 9. Negative 2 minus 4, negative 6. So we have 9 squared plus negative 6 squared. Next, simplify. 9 squared is 81. Then, negative 6 squared is 36. After that, you can now add 81 and 36. So, the answer is 117. So, square root of 117 plus, since this is not a perfect square, you're going to find for the factors of 117 that has a perfect square. And that is 9 and 13. So, 9 times 13, that is 117. So, since 9 is a perfect square, so you can get the square root of 9. So, square root of 9 is positive 3. And copy square root of 13. So, meaning to say, the distance between these points, M and N, is 3 square root of 13 units. In this part, you are going to try to find the distance between point A and point B using the distance formula. So for point A, we have negative 2, negative 5, and point B, we have 11, negative 3. Okay, so write your answer in a piece of paper, then send your answer through Google Classroom.